In this example, we're asked to consider the set U, which has elements A, B, C, D, E, F, and G, the subset X, which has elements A, D, E, and F, the subset Y with elements A, B, C, and the subset Z with elements C, D, E, and F. Based on this set and its subsets, we need to draw and label the Venn diagrams described here. We begin with a large square to denote our universal set. So all of these elements must be somewhere within this large rectangle. Now we can quickly verify that X, Y, and Z are all subsets of the larger set U, because every element in each of these is present in the larger set U. A, B, and C, A, B, and C, C, D, E, F, C, D, E, F. So we know X, Y, and Z are subsets, and in order to know how to represent these subsets within the universal set U, we need to understand, do these subsets overlap or have anything in common? So let's look. So looking at our three subsets, we see that A is an element that's common to X and common to Y. D is an element that's common to X and Z, as are E and F. So from looking at these different elements, we could say that X and Z overlap. Specifically, they overlap with the elements D, E, F. X and Y overlap. They both have A in common. And then Y and Z overlap. They each have C in common. However, the three subsets do not overlap. There is no element that's present in each of the three sets, so as I draw this and label the Venn diagram, I'm going to keep in mind that there's no element that belongs in X, Y, and Z. So we draw rather large circles for X, Y, and Z so that there will be plenty of spaces to label. And then we'll just label each of the circles for our subsets. This first one can be the subset X. Then we have the subset Y and the subset Z. What we now need to do is place all of the elements in the correct location of the Venn diagram. And you always go with the most overlapping areas first. So let's ask ourselves, are there any elements that belong to X, Y, and Z? Looking at what we wrote above, no elements belong to X, Y, and Z, so we're going to leave this empty. The next locations with the most overlap are the overlaps of two sets at a time. So we have the overlap of X and Y, X and Z, Y and Z. So let's identify which elements should belong in these locations. So for the elements that are common to both X and Y, we see that A is in both X and Y. And that's the only element that these two share, so I should label A here. And so that I can keep track that I've labeled A, I'm just going to check that above each A. Next, let's identify the elements in X and Z. Take a moment to think what elements are shared by subset X and Z. D, E, F is common in both X and Z. So we'll locate the elements D, E, and F in this subsection. Next up is the overlap of Z and Y. Think about what element is shared by Z and Y. We see that C is shared by both Z and Y. So looking at what elements we have not covered, we've listed where C, D, and F are, so we've dealt with everything in terms of Z. A, D, and F, we've dealt with everything in terms of X. However, we have not labeled B. B is supposed to be in the subset Y, but it's not shared with either X or Z, which means it needs to be in this section of Z, because this is a section of Z that is only elements of Z, not shared with subsets of Y or X. So here's B, so we've dealt with B. And then we look, as we've labeled all of these, we have everything listed here. So we have all of our elements. So this first step was just labeling our Venn diagram along with what elements go in which sections. Now we need to turn our attention to understanding exactly where is this in our Venn diagram. So let's first just read this left to right and translate the mathematical notation. X union the set Y union Z. And when dealing with any type of mathematical operations, if something's offset in parentheses, we're going to think about that first. So let's pay particular attention to where is Y union Z. Remember from our previous lesson, union is the idea of take everything in the first set and combine that with everything in the second set. So our first set was Y, so all of Y, I'll shade it in blue, is this. Combine that with all of Z, I'll shade Z in pink. So what we see drawn here is Y union Z. Everything in Y combined with everything in Z. So keep that in mind. That's our Y union Z. And it says we need to union this with X. Now union again is the idea of everything in the first group plus everything in the second group. Now X I'm going to highlight in green. So the union of Y union Z, which is in red, combined with X would mean everything in all of the sets combined together, and that would give us this overall section here. All three of the subsets represented by our circles in the Venn diagram. So the section of the Venn diagram that represents X union Y union Z is shaded here in purple. Now for our next problem, we still have the same original universal set U and subsets X, Y, and Z, so I've just recopied that here. And next up, we need to shade the section of the Venn diagram that's represented by X intersect the set Y union Z. Now, particularly intersections are a little more complicated to think about because instead of saying everything in the first set plus everything in the second set, we know from our definition of intersections in our previous section, the intersection of two sets are the exact elements they have in common. So in order to think what's the intersection of X and the set Y union Z, I need to know what both those things look like separately before I can determine their overlap. So off to the side, I'm just going to quickly shade a Venn diagram of X and a Venn diagram of Y union Z. So off to the side, I just quickly drew a blank Venn diagram with our X, Y, and Z. And we know the section that's X would be all of the circle for X. Y union Z would be all of Y, and then union means combine with all of Z. So we know what these two sets look like separately as a Venn diagram. And because we're asked for the intersection, we need to ask, what do these two things have in common? So let's just go piece at a time. So our set X This is the entire circle for x, but notice it has 4 separate sections, and we can think about these one at a time. Is this section shaded in both diagrams? Is it shaded in both the diagram for x and shaded in the diagram for y union x? Notice it's shaded here, but it's not shaded here. Since it's not shaded in both, it can't be shaded in the intersection, so we do not shade here. Next up, we think about this section. Is it shaded in both? It's shaded in the Venn diagram for x, it's shaded in the Venn diagram for y union z, so we will shade it in the overall diagram for the intersection. And we're just going to continue this in a systematic way until we've identified all possible shared intersections. So next, we'll identify the intersection of all 3. Notice it's shaded in x, and it's shaded in y union z, so we should shade it in the intersection. The last section of x is shaded in the Venn diagram for x. It's also shaded in the Venn diagram for y union z. Intersection means whatever is shared in both is in the intersection, so we should shade it here as well. Now we stay focused. So far we've dealt with all of these. So let's continue to check the remaining pieces of our Venn diagram. Looking at the section that is z alone, that's not intersected with x or y, we notice it's not shaded in the top. Even though it's shaded in the bottom, y union z, if it's not shaded in both, it's not shaded in the intersection, so we're going to leave this blank. The intersection of y and z is not shaded in the Venn diagram for x. It is shaded in the Venn diagram for y union z, but we know for intersection it has to be shaded in both, so this will also be left unshaded. So far we've dealt with all of these sections. So all that's left to check is this for y. It's not shaded here. It is shaded here, but it has to be shaded in both, so it's not going to be shaded here. And then finally notice the outside section, the part that's in the universal but not the subsets, is not shaded in either, so it will not be shaded in the intersection. So we've now found exactly what part of the Venn diagram represents x intersected with y union z. And my hint to you is, especially for intersection problems, draw each of the Venn diagrams separately and then ask yourself, where do they overlap? Where they overlap is what I'm going to shade in the overall Venn diagram. Continuing with our next example, we have the same original setup of our universal set, subset x, y, and z. So I've just copied the Venn diagram that we figured out in our previous example here. And I'm asked to shade the Venn diagram that describes the set x union z, union y intersects z. Now, particularly whenever we're asked to shade Venn diagram problems that have multiple intersections or unions, it can be helpful to do smaller Venn diagrams off to the side and then think, how do you link it all together? So what I'm going to do is I'm going to first figure out, what does x union z look like? Then I'm going to determine, what does y intersect z look like? Once I know what these look like separately, I can conceive of what the union of those two sets should look like. So remember, x is all of this circle as labeled. Z is all of this circle as labeled. And union means combine everything from each together. So x union z will be both of these circles completely shaded. Now I'd encourage you to take a moment and pause the video and attempt to shade the portion of the Venn diagram that's representing y intersects z. Unpause to check your work. So we know y is all of this circle, z is all of this circle. We know intersections mean only shade what's common to both. So as you look at each of these two pieces, the Venn diagram, the subset y, the subset z, the only thing they both have in common is this section. So only this section, when shaded, will represent y intersects z. So now that we understand what both of these Venn diagrams look like separately, let's consider what should it look like for the union of these two. Remember, the idea for set operations union is everything in the first plus everything in the second. Pause the video here and attempt to shade the overall Venn diagram on your own. Unpause to check your work. So we know the way union works is it's everything in the first plus everything in the second. So I'm going to shade everything from the first. And then I'll shade everything from the second. But as I was shading the first, I actually happened to already shade everything from the second. It was just included. So this is x union z, union y intersect z. And that's our overall Venn diagram. Now looking towards our next problem, it's actually very similar. We have the same x union z and the same y intersects z. The only difference is instead of linking them by the union symbol, we now link them from the intersect. So what we're going to do just to speed things along is let's recopy our Venn diagrams for x union z, y intersects z, since those would be the same for this next problem. So as before, x union z is everything in x and z together. Y intersects z is only what the two sets share, which is this area. And then as we think about intersecting these two Venn diagrams, intersection symbol, we will only shade what they both share together. So remember, if it's shaded in both, it's shaded in the overall for intersections. This portion is shaded in the first one. It's not shaded in the second, so we don't shade it in the overall. This section is shaded in the first. It's not shaded in the second, so we do not shade it overall. This section is shaded in the first, not in the second. However, this section is in the first and the second, so it will be shaded overall. This is shaded in the first and the second, so it will be shaded overall for our intersection. And then no other portion of the Venn diagram is shaded in both x union z and y intersects z. So this will be the result of x union z intersect y intersects z. Our final Venn diagram that we need to shade is reading left to right. X, and remember this apostrophe should be read as complement, so x complement intersect the set y intersects z. So this problem has a lot of ideas included. It has the idea of the complement, the intersection of two different sets. So we would do well to make sure we understand both of the sets separately before we consider their intersection. So off to the side, I'm going to draw a Venn diagram and shade it for x complement. And I'm going to draw a Venn diagram and shade it for y intersects z. And then once I have both of those written, I can consider what would their intersection look like. So we quickly sketch off to the side small models of our overall Venn diagram. And then we just need to think back to our definitions. The complement of a set is everything outside of that set. So to figure out what x complement would look like is we first figure out what is x, and then we shade everything outside of x. So x is this entire circle in our Venn diagram. So in order to represent x complement, we would need to shade everything outside of x. So our x complement should be all of that. Now y intersects z. Y is all of this. Z is all of this. And then intersect is what they have in common. So the intersection should be here. So then as we think of shading our overall diagram, we know what each of these looks like separately. So now we need to consider what would their intersection look like. We know intersection is everything that's shaded in both diagrams is shaded in the overall diagram. I'd encourage you to pause the video now and attempt the rest of this problem on your own. Unpause to check your work. Now, particularly when I'm dealing with intersections, if one of the Venn diagrams that I drew off to the side is more restricted or less shaded, I'm going to start there first, because in order to be in the overall intersection, it has to be in both. So for instance, the only thing shaded in the second graph is this portion, of which when we look to the top graph, only the portion shared exclusively by y and z is shaded in it as well. So only this section and this section. These are the only two sections that are shaded in both Venn diagrams. So it would be the only thing shaded overall. And then that would be our overall intersection of x complement intersected with y intersects z. So as you attempt these Venn diagrams with multiple subsets or intersections, unions, or complements, be sure to draw your simpler Venn diagrams off to the side and then think, how would you draw the overall diagram based on if you're intersecting those things or unioning those things.